let's go ahead and talk about end behavior. So end behavior is exactly what it sounds like. It is what is happening to our graph as at the ends of the graph. So basically, if we look, let's just look at the y equals x, the linear function. If we trace these ordered pairs, and we notice, so here we're about -1, -1, -2, -2, -3, -3, -4, -5, so on and so forth. So as our x values are decreasing, so are our y values. Now, if we go and look at where our x values are increasing, so 4, 5, 6, we notice that our y values are also increasing. Okay, so what does that look like? Well, it looks like, if we look at our end behavior section here, what this is saying is as x goes to infinity, y, remember that's just a fancy way of writing y goes to positive infinity. So remember, this is just saying that when our x values are increasing, our y values are also increasing. Then if we look at this next section, this says as x goes to negative infinity. So that's as our x values are decreasing. Our y values, f of x, are also decreasing. So we'll put negative infinity there. Okay, so that was what our linear function looked like. At our quadratic function. Now our quadratic function is if we look at this side right here, notice that our x values, are decreasing. So they're getting more and more and more negative. Our x values are getting more negative. But look at what's happening to our y values. Our y values are increasing. So what's that going to look like when we write it down? When we write it down, I'm going to go ahead and make a note right here. So for our quadratic end behavior, we're going to say as our x values were decreasing or going to negative infinity, our y values, those were increasing, so they're going to be going to positive infinity. Okay, now let's go ahead and look at the other side. Now here, our x values are getting more and more and more positive, so they're increasing, and our y values are doing the same. So as we write our end behavior here, we're going to write as x goes to positive infinity, because we were going to the right that time. Our y values, our f of x, were going to positive infinity because they were increasing as well. Go ahead and look at our end behavior of our cubic function. So if we'll notice, if we look at our end behavior, so we're looking down here and up here, that looks really, really similar to our linear function. If we go back and we look at our linear function, it looks very similar. And what we'll notice is that, in fact, as our x values are decreasing, so let's say, for example, here, right, our x value is, we'll call that -1.5, and our y value is -3. Okay, and then here we had -2 and -8. So our x values were decreasing, as were our y values. So what I'm going to do is let's go ahead and let's look at our end behavior for the top part of the graph. Now, in this case, it was just like in our linear functions. Our x values are increasing, and so are our y values. So they're going to positive infinity there as well. So let's look at our statement here in our end behavior section. It says, as x goes to positive infinity, so that means our x values were getting bigger. Our y values, we know they were also getting bigger. Then as x is going to negative infinity, so we saw that when our x's were going to the left, getting smaller, our y values, in fact, were also getting smaller. Remember, that was exactly like our linear function. Okay? All right. So now let's talk about increasing intervals. Oh man. All right, so now let's talk about increasing intervals and decreasing intervals. So what's important about these is it's important for us to know what's happening in our graph, especially now that we're looking at graphs and functions that we're not really used to. And so as with so many other things, when we're looking at increasing and decreasing intervals, we always want to read the graph from left to right, okay? So as we look at the left-hand part of our graph, so that means we're going to be kind of down here in this area, what is happening to our y values? Well, right now, our y values are increasing, okay? And it looks like that's pretty much happening throughout our entire graph. Our y values are increasing. So for our increasing intervals, because that's what's happening through our entire graph, we just say that it's increasing from negative infinity to positive infinity. Now, a decreasing interval would look something a little more like this. If it looked like this, that would be a decreasing interval, because from the left to the right, we would be going, quote, downhill. So that's what a decreasing interval would look like. And in this particular case, there is none. There's no decreasing intervals whatsoever, okay? So we're always going to read our graph left to right. So there's our basic information about a cubic function. So now let's go ahead and move on to a quartic function. So what does a quartic function look like? Well, just like a cubic function meant that y was equal to x cubed, a quartic function means that y is equal to x to the fourth power. The word quart, quarter, quartic, that all kind of goes with the word four. So we're going to go ahead and use Desmos because it's my favorite. And we are going to look at what our quartic function looks like. Now that's really interesting because that looks very, very similar to our quadratic function. And we also discussed, let me go ahead and put our cubic function back. Our cubic function and our linear function looked really similar. So that's kind of an interesting observation. Either way, let's look back at our quartic function. So here's our quartic function. Let's go ahead and take that and let's make a table out of it so we can kind of see what's going on. And here's our table values, and we can see those points that are plotted. And let's go ahead and transfer this information to the to your notes. So when we do that, basically we know that when we have -2, that gave us a +16, and that comes from -2 to the fourth power. -1 gives us a +1, 0 gives us 0, 1 gives us 1, and 2 gives us 16. Same reason, 2 to the fourth is equal to 16, 1 to the fourth is equal to 1, 0 to the fourth, and then of course -1 to the fourth power is also equal to +1. So graphing that, I'm going to go ahead, so there's our 0, 0, our 1, 1, and then we go all the way up to 16, so here and here. Now, it would be tempting to go ahead and draw this in just like we would a quadratic. And it does. It looks very, very, very similar to a quadratic function. But let's just go back and look carefully at what's happening right here. So I'm very interested to see. I'm going to go ahead and take that away and put in our... There we go. Okay, so let's look at these numbers here. So right here we're at 0, 0. Okay, and as we're getting, so notice how, right, we're growing very, very slowly, very, very slowly, and then that growth starts to kind of pick up. So this isn't necessarily what we would call a vertex, so to speak. I mean, it is, but it doesn't act the same way that our other one did. So it's a little flatter right here than our quadratic one is. Okay, so but this graph right here is very difficult to even zoom in and kind of get that general shape. So if your sketch looks like a quadratic function, then that's perfectly okay, because it's very difficult, especially with a graph this small. All right, go ahead and fill in your domain and range. Okay, so there's your domain and range, also your x and y intercepts, and your maximum or your minimum. So in this case, that point that we talked about earlier that was at the origin, that is going to be our minimum. Okay, all right, so now let's look at the end behavior. So our end behavior, it looks very much like the quadratic function, and in fact, the end behavior is the exact same as the quadratic function. So as our x values go to positive infinity, so that's going to be over here in this area, our x values are getting larger, our y values are also getting larger. So x is going to positive infinity, our function f of x is also going to positive infinity. Now, as x goes to negative infinity, so that's going to be on this other side right here, our y values are still increasing. So they are still going to positive infinity. All right, now let's look at increasing and decreasing intervals. Remember, we're always going to go from left to right. That's how we're going to read it. And our increasing intervals are when we're going uphill, and our decreasing intervals are going downhill. Okay, so uphill and downhill. So looking at our graph to the left, on the left-hand side, if I were to imagine moving along that, I would very clearly be going downhill. So that is a decreasing interval. So what we're going to say is that our decreasing interval is from negative infinity to 0. And we're always going to name these off of our x values. Okay, so they're named by the x values. So at this arrow is where we have our negative infinity x value, and our y value, or sorry, our x value here is going to be 0. So that's why our decreasing interval. But then if we keep going, now we're going to be going uphill. And so that increasing interval is going to be from 0 up to positive infinity. Now, I also should have been more careful about my notation here, because clearly, and you guys probably have already caught me on it, that should have been a square bracket, and our 0 here should be a square bracket. But of course, when we have infinity, we're always looking at a circle bracket. All right, so that is how you identify cubic and quartic functions, and you learned Couple of new concepts. You learned the end behavior and the increasing and decreasing intervals. Okay. So now let's go ahead and talk about these polynomial transformations. And this should look very familiar to you, okay? It should look very, very familiar to you. Now, when we have our A, B, H, and K, remember when we had our y equals a x minus h squared plus k, and that was for our quadratic. So we have the same situation here. And remember, again, we do have this b value, and we know that this b value is horizontal compression and stretches. Now, we need to know that those are there. We need to know that they exist. But just like before, we're really not going to use them just a whole lot in Algebra 2, but you will use them in pre-calculus. Also, there should be an edit right here. This should be K. This should be H. I apologize for that. Okay, so here's what I'd like to do. What I'm going to do is I am going to graph the parent function. So this is a cubic right here. So I'm going to graph those points. 1, 2, 3, 4, 5, 6, 7. It's going to be 8 back here that we had before. 1, 2, so here. Okay, so those are our points from our cubic function. And I'll even kind of sketch that in just a little bit. Okay, all right. So now we have our cubic parent function. So then let's look at these transformations that are occurring. So we have a -1 inside the parentheses with the x. So that means that we're going to be going right one space. So what I'm going to do is I'm going to take each one of these points and I'm going to move them to the right one space. All right, then we're going to look at our +3. That means that we're going to take each one of these points now, and we're going to move them up 3 spaces. So that means this one's going to go way up here, and then 1, 2, 3. This one's going to go here, 1, 2, 3 here. Red there, 1, 2, 3 there, and then 1, 2, 3 right there. Okay, so our new function is going to look something like this. So the black one was our original function. The new one is what's in there now. Okay, so I'm going to go ahead and go look at Desmos, and we're going to see if we are correct. So over here in Desmos, we're going to be working with our cubic function. I need to type that back in. There we go. And then we're going to do the y equals, and it was parentheses x minus 1 cubed. And then it was what? +3. So +3. Okay, so there we go. And that looks real weird. Okay, back here. So if we look at these points, we've got our 0, 2. So that's that. Did we have that in here? 0, 2, right there. We sure did. Yep. And then if we come in here and let's put our table back in like it was before, then we can look. We had -1, -5. So let's look at -1, -5 right here. And we had 1, 3, and 2, 4. So 1, 3 here, and 2, 4 right here. So there we go. I'm going to go ahead and erase the parts that we don't need, but it's a good visual to see how these things even come about, I think. All right, so there we go. Same thing here. So what I'm going to do is I'm going to go ahead and plot the points that I know are in my quartic. This is a quartic function, my quartic. And what I'm going to do is I'm going to take each point and I'm going to move it to the left 6 spaces. So 1, 2, 3, 4, 5, 6 right here. And then I'm going to move our other 2 points and then move these up here at the top. And of course they are, you know, off the graph, so that they're just kind of a guesstimate. And then just to make things a little cleaner, I'm going to go ahead and erase those ones. So I've done that part. Now I'm going to go ahead and move them to down 4 spaces. So 1, 2, 3, 4. And then we're here and we're here and we're still going to be somewhere around here. Okay. Then, so I'm going to go ahead and erase the red. Okay. And now I'm going to deal with this -2. So here's what I know. I know that our negative is going to make all of these, it's going to flip it, right? So instead of these points being here, they're actually going to be here. And then these points are actually going to be somewhere way down here. That again, we don't know. And since it's getting a little messy, I'm going to go ahead and just erase them. All right, so we're there. But then we also have this, and I should have made the green be that negative because that's how we flipped it. And then we'll make this 2. So what we're going to do is we're going to stretch. Remember, that is a vertical stretch. So instead of this point here being 1, we're going to stretch it up to 2. So there we go. So here are the ordered pairs that I'm dealing with. So I've got -6, -4, and then we have -7, -6, and then -5, -6. So let's come over here to Desmos. I'm looking at that, and that's what I see. I see -7, -6, -6, -4, -5, -6. So there we go. All right, so we are dealing with, so this one, we don't actually even have to graph, right? All we have to do is describe the transformations. We just have to write down what they are. So we've been doing this forever and ever, right? So this one is going to move us to the right 3 spaces. And then this one is going to move us up 4 spaces. Then this is a compression. It's a vertical compression. And our negative sign is going to be a reflection, a vertical reflection. And that's it. That's it. Okay. Now, notice that notice how example 3 and example 4 look different. So what you'll notice is that this -2 right here is actually inside of the parentheses. So that's actually that B value we talked about. And so that is actually going to be a horizontal stretch. No, that's a compression, horizontal compression. Let me double check because I don't work with them very often. Greater than 1, compression, perfect. So that is a horizontal compression and reflection. then everything else is like it is. So that's going to be to the right. Sorry, not to the right, goodness. To the left, 7 spaces. And then we're going to be down 12 spaces. Okay. So we want g of x that is reflected across the x-axis. So we're going to put a negative there. Horizontally stretched by a factor of 2/3. So horizontally stretched, that means that number is going to go inside of the parentheses. So 2/3. Translated 5 units to the right. I'm going to do a different color here. 5 units to the right. So that means we're going to have an x, and it's going to go to the right. So we have -5. And we'll close that parenthesis. And that is going to be, let's see, g of x is a cubic function. So we have a 3 exponent. And then translated 7 units down. So 7 units down, -7. So let me make that a little cleaner for you. G of x is going to be negative, parentheses, 2/3, parentheses, x -5, close, cubed, -7. Okay. All right, so let's talk about how we would write this in function notation. So here's what I'm going to do. I'm going to go ahead and put in here f of x, because that's what we're changing. It's going to be equal to g of x, but we're going to be changing f of x. And here's what we know. We know that it's reflected across the x-axis, so that means that it is going to be a negative a. So it's going to be outside, like in the front of the function. Then we know that it's horizontally stretched by a factor of 2/3. Now, since it's a horizontal stretch, it's actually going to be inside of the function. So that means that it's going to be there, inside of the function, but in front of the x. Then we have that translated 5 units to the right, which is -5, and 7 units down, so -7. Let me clean that up for you just a little bit. That is going to be g of x equals negative, that's that reflection across the x-axis, f of, and we can do this. So f of 2/3 times x -5 -7. And that's it. All right, so let's do the next one. And I'm actually going to do the next one starting with function notation. I personally think it's a little bit easier because then all we have to do, well, I'll explain it in a minute where I think it's easier. All right, so again, we're going to start with this f of x. And I'm going to leave some space because I know that there's going to be a bunch of stuff happening. So here we go. We've got a reflection across the y-axis. So when we reflect it across the y-axis, it means we're going from here to there, right? So that's a horizontal reflection. Let me erase that so it does so it doesn't, anyway. It's a horizontal reflection, which means that it is going to go in front of the x, but inside of the function. And it is vertically compressed by 1/7. So that means the 1/7 is going to go in front of the function. Translated 1 unit left. So that means that we're going to add 1. And then 9 units up. So we're going to add 9 at the very end. Okay, so here's why I feel like this is so much easier. We're going to do 1/7. And then instead of the f, we're going to put the exponent because it's the kind of function it is. And then from there, it's the same. So I think personally, I feel like that's a little bit easier.